Now that we finished lesson 1.3a, you can go ahead and turn your paper over, or if you printed it on a separate sheet of paper, we're going to head into lesson 1.3b. As you can see in lesson 1.3b, the major concept or idea that you needed to take away from this lesson was knowing what equivalent expressions are or how to find equivalent expressions. So as I look under here, it says equivalent expressions, expressions that are the same and equal to each other even though they look a little different. So equivalent expressions are basically two different expressions that when you look at them and compare them, they at first look very different in the way that they're written or in the terms that they have. However, when you take time to simplify each of those expressions, whether that's using the distributive property and or combining like terms, they actually are equivalent or they're equal to the same thing. So in my example below, I have the question, what expressions are equivalent to in this example? So this example has 1, 2, 3, 4, 5 terms in this expression. So what we need to do is think about how this expression may be equivalent to one of these or more than one of these 4 choices below. Therefore, as we chatted in class, the best way to decide if expressions are equivalent is to, of course, simplify them. So when I look at this expression or this 5-term expression here, I notice there's no parentheses. So I don't have to worry about using the distributive property. And I can go ahead right to step number 2 from the previous page that we just talked about and think about what terms I can combine. So if I look at my first term, I see that there's an x squared. But when I scan over all the other terms that remain, I don't see any other x squareds. So x squared doesn't have a like term. Therefore, in the next step, I'm just going to copy that x squared down because nothing else can be combined with it. I then notice I have a negative 3x as my second term. And when I scan to my last 3 terms that follow, I notice some of the other terms have x's. So those must be the terms I have to combine. Therefore, I'm going to circle negative 3x, negative 4x, and a positive 2x. These are all terms, or these 3 terms have a variable or the variable x in common. Therefore, I can combine those values. So if I think about negative 3, so again, thinking about if I'm at negative 3 on the number line and I subtract 4 more, I actually end up at negative 7. And when I'm at negative 7, but add positive 2, I end up at negative 5. And because they have an x, I bring that x along with it. So negative 3x minus 4x plus 2x gets me to negative 5x. And then this constant plus 12 is out at the end. Again, there's no other constant, so I'm just going to copy down plus 12. So now when I look at my expression, every term or every like term has been combined. And what's nice, step 4 is already taken care of because everything is written from highest exponent to lowest exponent with my constant being at the end. So this is the simplest form of the expression in my problem. Therefore, now what I have to do is I have to compare all these other expressions to that simplest form answer and see if that they are actually the same thing or mean the same thing. So let's start with number 1. Number 1, I see a set of parentheses and a number or a variable that's out front that I need to distribute. So here I need to begin with the distributive property in order to simplify. So I'm going to go ahead and distribute the x. Therefore, x times x is x squared, and x times positive 5, so this is distributive property over addition, gets me to plus 5x. And I'm going to copy down the 12. So in this simplest form, I can see it's in simplest form because none of these 3 terms now have like terms, and they're written from highest exponent to lowest exponent. But when I compare this answer to the top, yes, they both have an x squared. Yes, they both have a 5x, but what I notice is the one in my problem is a subtracting or a negative 5x, and this one is a positive 5x. So even though they have an x squared and a 12 that are alike or that are equal, the 5x, they're different. One's negative and one's positive. Therefore, option number 1 is not equivalent. So I'm going to put a big X through it. and I can even write a note off to the side. Not equivalent. All right, number 2, x squared plus 5x plus 12. Well, here there's no parentheses to distribute anything. There's no like terms to combine. And actually, when I compare it to the problem, the number 1 problem that I just got done, those were the same answer. And I already know that number 1 is not equivalent to my problem. Therefore, number 2 can't be equivalent either. So I'm just going to go ahead and X it out and write not equivalent. Number 3, there's no parentheses, so I don't need to distribute. There's no combining like terms either because this is a negative 3x and a positive 12. Can't combine those together. And it's written from highest exponent to lowest exponent. So this expression is already simplified, but obviously when I compare this expression to my problem, there's nothing in common there, or they're not equivalent. Therefore, they're not the same. So I can put another x and write not equivalent. Finally, then for number 4, I just don't want to assume that this is an equivalent expression of the problem. And as I can see, there's a lot of parentheses in terms that I'll probably have to combine. So because of the parentheses, let's go ahead and focus on distributing first. So x times x is x squared. X times negative 3 is negative 3x. That takes care of the distributive property over subtraction in the first part of my expression. So then I see that there's a negative 4x, but nothing is being multiplied, or I don't need to distribute that, so I'm just going to copy it down. And then I see a positive 2 that's out in front of my parentheses here. And because of that, that means I need to use the distributive property. So again, I have a positive 2 times x to get a positive 2x, and a positive 2 times 6 to get a positive 12. So after I did the distributive property twice, I can now see that I have a 1, 2, 3, 4, 5-term polynomial. And if I just take a brief moment to compare polynomial. So polynomial we'll talk about way later in the year. I meant to say expression. Those words can be used interchangeably, so sorry about that. But this is a 5-term expression. And if I look at this 5-term expression, it looks very similar, if not exactly alike, the expression I started with in my problem. But just to confirm if this is equivalent to the answer I got above, I can now again see that the terms I need to combine are all the terms that have x's in them. So if I bring my answer over here, again, I'm copying the x squared because there's no like term. Negative 3x minus 4x ends up at negative 7x. But plus positive 2x gets me to that negative 5x. And then I go ahead and copy the plus 12, which is just the constant. So again, this expression is now in simplest form. It's written from highest exponent to lowest exponent. And when I compare this answer to the top, this expression is equivalent to that one. So this one, I'll put it like a little nice smiley face. And this, I'll write equivalent. So again, even though this problem, to begin with, looked different than the expression I had written initially, they still ended up simplifying to have the same expression or have the same answer. Therefore, we call them equivalent. I'm getting close to being done with this video's time limit. So in the next video, kind of to branch off of or further investigate what equivalent expressions mean, on a separate sheet of paper, I'm going to go over and prove to you why in these 3 problems, the expression on the left is not equivalent to the expression on the right. And the reason why I'm going to go through this now at this point is because these 3 problems is where I see the most mistakes being made in terms of thinking that they're the same when truly they're actually different. So I'm going to go ahead and stop this video. And so can you just get an extra piece of paper or a sticky note to attach or staple to these summary notes?